welcome back. So today in this video we'll explore how to implement a linked list using an array. So we'll start with quick recap what linked list is, discuss why you might want to implement using an array, and then walk through the implementation step by step. Let's get started. First, let's recap what a linked list is. A linked list is a linear data structure where elements called nodes are connected via pointers. Each node contains data and a pointer to the next node. There are different types of linked lists: singly linked lists, doubly linked lists, and circular linked lists. Why would we use an array to implement a linked list? Here are the few reasons. First, contiguous memory. Arrays allocate memory in a block, making it easier to manage compared to dynamic memory allocation. Second, no dynamic memory overhead. In languages like C, where dynamic memory allocation is manual, using arrays simplify the process. Third is simplicity. Implementing a linked list using arrays help you to understand the core mechanics of how the pointers and nodes work. While this approach has some limitations like fixed size, it's a great way to learn the fundamentals. Let's dive into the implementation. Here's how we'll do it step by step. First, defining the arrays. We start by defining two arrays: data to store values and next to store pointers. Initially, all values in data are 0 and all pointers in next are set to -1, indicating the end of the list. Next, we initialize the next array. Each element is set to -1, which means there are no connections between nodes yet. This represents an empty linked list. Now, let's insert some elements. We add 10 at index 0, 20 at index 1, and 30 at index 2. After each insertion, we update the next pointers to link the nodes. For an example, after inserting 20, the next pointer at index 0 is updated to 1, indicating that 10 points to 20. To traverse the list, we start the head, index 0. We print the value at data array, data 0, which is 10. And then we move to the next node using next 0, which points to index 1. We repeat this process until we reach -1, indicating the end of the list. The output is 10 to 20 to 30 to none. To delete a node, we update the next pointers to skip the deleted node. For an example, to delete 20 at the index 1, we update next from 1 to 2. Now the list skips the index 1 and the traversal output is 10 to 30 to none. To make this more relatable, let's use a real-world analogy. Imagine a train where each compartment is a node. The array is like a train schedule that tells you which compartment comes next. For an example, the first compartment, which means node 1, points to the second compartment, node 2. The second compartment points to the third compartment. The third compartment points to none, indicating the end of the train. This analogy helps visualize how pointers work in a linked list. So that's it for today's video. We've successfully implemented a linked list using arrays, and I hope you found the step-by-step breakdown helpful. Let's quickly recap what we covered. First, we define two arrays. We initialize the next arrow -1, indicating the empty list. And we insert elements like 10, 20, 30 to updating the pointers to link the nodes. We traverse the list, printing the values by following next pointers. Finally, we deleted the node by updating pointers to skip the deleted element. So this approach is a great way to understand the core mechanics of linked list, especially in languages like where dynamic memory allocation isn't straightforward. So if you enjoyed this video, don't forget to like and subscribe. So thanks for watching. See you in the next video. Happy coding.